Module 4 shows how to perform a large displacement static analysis of a cantilevered beam having an elastic material. This is the second of 4 videos contained in Module 4. This video shows how to set up the analysis parameters and how to submit the analysis. The analysis type is MES with nonlinear material models. The MES stands for Mechanical Event Simulation. This type of analysis can also be applied to large displacement analyses having linear materials. To edit the analysis parameters, we select Analysis Type and then Edit Analysis Parameters. There are several types of analysis parameters that can be specified. This includes event information, load curves, gravity and acceleration, thermal, electrical, and output. There are also advanced features that can be accessed. We will set the event duration to 1 second. Some mechanical event simulations involve dynamic loads or time-dependent materials. We do not have either of these, so the time selected is arbitrary. The capture rate is used to define the number of increments used to apply the loads. Since we are interested in the deflection history, we will specify 5 load increments. We will be able to see the deflection of the beam and the associated stresses at each of these load increments. The load would be applied in 1 increment if this number were set to 1. Next, we will define the load curve that controls how the load is applied as a function of time. In our case, the load will start at 0% at time equals 0. It will increase to 100% at the end of the event or at time equal to 1. If we plot the load curve, we will see it starts at 0, increases linearly to a magnitude of 1 for the multiplier at a time equal to 1. Next, we will set gravity to act in the negative y direction. We set the direction cosine for the y multiplier to -1 and set the acceleration due to the body force to 386.4, which is the magnitude for an inch-pound-second system. Next, we will select the advanced features. The first tab will allow us to specify the type of equilibrium iteration to be performed and its associated convergence tolerance. There are 6 different types of equilibrium iterations that can be performed. These include Newton with line search, a modified Newton with line search, a combined Newton with line search, and those 3 options without line search. We will select a full Newton without line search. This is based on having done previous analyses and observed which of these methods has the best convergence. We observed that the modified Newton did not converge and that the full Newton with line search had poor convergence properties. It may be necessary to run multiple analyses to determine the type of iteration method that is best suited for a particular problem. We will use a displacement-only convergence criteria, and we will use the default displacement tolerance. We are now ready to submit the analysis, and we will do this by closing these boxes, selecting analysis, and pressing the Run Simulation icon. In the next video, we will examine the information displayed during the solution process. This completes this video.